Okay, so today we're going to talk about what is the speed of Q when x is equal to 20 feet and what is the maximum speed of Q. So this more or less is going to be like a train wheel that's going around. It's connected with these particular arms, and this is Q, P, and then this is origin, which is O. So between P and origin, we're going to have a 90 degree, and then our radius is 10 feet, and in the x direction is 20 feet. We're going to let our dq dt equal to pi divided by 30 per second. So it's going around pi divided by 30 per second. So the first thing we want to do is find the specifics and general equations. So our specific equation in this particular case is going to look like this. So let's look at this as being, take our triangle here and move it over to here. And this is going to end up being 20. This will end up being 10. This will be our theta. And then, of course, this will be 300 square root. And in our specifics, we're not going to take cosine, but we're going to take secant. So the secant theta is going to be equal to hypotenuse over adjacent. So our secant theta in this case is just going to be 20 divided by 10. And this is feet, so that's going to cancel. So our secant theta in this particular case is going to end up just being 2. This is going to be important, so we're going to keep this. The next thing we want to do is find out this is our specific. Let's find out our general equation. So let's look at this. We're going to do the same thing we did before. This is going to be 20. This will be our theta. This is 10. This is 300 square root. Let's look at the general equation. So our general equation is, we don't know this, so let's going to make this just be x. So now we have secant theta is going to be basically x over 10. Therefore, x is going to be equal to 10 times the secant theta. This is our general equation. These two are both going to be important. Let's look at our general equation. We're going to take the derivative of this thing to find out the velocity of Q. So x is going to be equal to 10 times the secant theta. So dx dt, don't forget to use the chain rule, is going to be dx d theta dt. Very important part, very important step, not to forget the chain rule. All right, so we already know d theta dt. Let's look what dx dt is, or dx d theta is. So dx dt is going to end up being secant theta tangent theta, once we take the derivatives of those, times the most important part, d theta dt. All right, so let's see. We already know secant. We already know that as being 2. We don't know what tangent is, but I do know this formula. I do know this identity, that tangent theta is equal to secant squared minus 1. Secant minus 1 square root is the same thing as tangent. So now we can just put our numbers in. We know what x is. We found our general equation. We know our specific equations. So let's see what dx dt is. Dx dt is going to be equal to secant theta, which is 2. Our x is, 10 feet first, and then our secant. And this would be 2. Tangent would be 2 squared minus 1, which would be 3 square root. And then d theta dt is pi divided by 30 per second. So there's a lot of math here. Once we do our math, dx dt, feel free to do that in the calculator, is going to be about 3.63 feet per second. And that is our velocity at q, velocity of q. That's about 2.47 miles per hour. I think it's 47. Yeah, 47 miles per hour. So miles per hour. All right. Now, what's the maximum speed? I'll save a few minutes there. You can take a picture of the screen if you like. All right, so what's the maximum speed? So we found out our speed, but what's the maximum speed going to come out to be? The maximum speed is when x is going to be all the way out to this point. So that's going to end up being when x is at its maximum. So if we roll this thing over this way, like our maximum x is going to be 10. So x max is going to be 10 plus 300 square root, which comes to about 27.27, I think it is, 27.732 feet. So we just plug this in here now for over to here to find our secant. So our secant theta now is not going to be 20 divided by 10, but 27.32732 feet divided by 10 feet. And now our secant theta is going to be something like 2.7732. I think it's what it comes out to be. So we just do this. We play the same game. We found out that our dx dt is going to be 10 times the secant theta, tangent theta, times d theta dt. Plug our numbers in. And last time we used 2, now we use 2.7 dx dt. This is going to be our maximum, is going to be equal to 10 times 2.7732. This is feet. And we're going to get 2.7332 minus 2.7732 squared minus 1 square root, whatever that number is, times pi divided by 30. And don't forget now, our d theta dt is that. And dx dt, sorry, I'm running out of room. Dx dt ends up being at the maximum about 7.274 feet per second. So that's our maximum speed. And that's approximately about 5 miles per hour. Okay, so there you have it. This is what is the speed of q when x is equal to 20. So basically it's like a train wheel going around. What is the speed of q? We're going to first look at secant, take our triangle, look at secant, find the general, then find the specific, put those numbers into it, take the derivative of the specific or general. Once we take the derivative, we're going to find our speeds. I hope this helps. Thank you and subscribe.